Hi, Mr. Richards here, and today's lesson is on compare properties of functions. Our real-world link involves a trip to the Science Museum. Carlos's annual membership to the Science Museum can be represented by the function c equals $29.99, where c represents the cost in dollars. The cost for Stephanie to pay per visit is shown in the table. And so we have visits 1, 2, 3, 4, 5. And the cost is $1, $10, $15, $20, and $25. So in order to make a table to represent Carlos's membership, well, for months and visits, I guess we can consider the same thing here. We have 1, 2, 3, and 4. Now, we're going to multiply those months by, well, nothing. Look, the function is just $29.99. So for either one visit, 1 month, that's going to be $29.99. For 2, $29.99. For 3, $29.99. And for 4, $29.99. Woo! Now, at first, it's like, wow, one visit for Stephanie is only $5, but for Carlos, it's $29.99. But as we get closer to 5 visits, Stephanie's is $25, and Carlos is still at $29.99. So eventually, as we compare the properties of these two functions, we'll see what happens. Now it says, describe the rate of change for each function. Well, when we look at Carlos's rate of change, this rate of change, there is none. So we could say the rate of change is 0. Compared to Stephanie's, her rate of change is $5 per visit. And where does that $5 come from? Well, for each visit, we're going from 5 to 10, we're increasing by $5. 10 to 15, increasing by $5. 15 to 20, increasing by 5. 20 to 25, increasing by 5. So her rate of change per visit is $5. Now, who pays more for 2 visits? Well, Carlos for 2 visits, that cost is going to be $29.99, as we can see from the table. For Stephanie, for 2 visits, she's only paying $10. So, Carlos. Who pays more for 6 visits? Well, we don't have that number quite yet for Stephanie, so if we just look back at our table and say, okay, for a 6th visit, we can assume we're going to increase still by another $5, and so this is going to be $30 for her. Now, since Carlos doesn't have a rate of change, 5 visits would cost $29.99, and 6 visits would cost, well, still $29.99. And so who pays more for 6 visits? We compare the two. Carlos is still at the $29.99, whereas Stephanie is now up to $30. So Stephanie, and this is going to be by, well, for now, just a penny. So throughout this lesson, we're going to compare properties of functions represented in different ways, both tables, graphs, and even as an equation. And we can actually throw words into these comparisons as well, as functions can be represented by a table, graph, equation, or words. You can compare 2 functions represented in different forms. So as we look at our example 1 here, a zebra's main predator is a lion. Rawr. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. Compare the speeds. Well, the lion, as we said here, is 53 feet per second, and we can just take that right from the problem. With the graph of the zebra, what we're going to do is to find the rate of change or the slope of this line. And so we picked out 2 points, 159 and 118, with the time being in seconds and the distance here being in feet for our y. Our change in distance was 118 minus 59 to get us to 59. Change in time was 2 minus 1, or 1. So 59 over 1 means 59 feet per 1 second. And so we can compare the zebra's 59 feet per second to the lion's 53 feet per second, and the zebra's speed is greater than a lion. So if the zebra's main predator is a lion, it's a good thing it's faster. So as we go to try this on our own, a certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sport utility vehicle is represented by the function shown. Compare their gas mileages. Well, here we have the car having a gas mileage of 22 miles per gallon. So, we need to figure out, just like the book did in example 1, what is our rate of change or slope of this graph? Well, if we pull out 2 points, say we pull out 238, and just for a challenge, let's go to 476. Well, if we look to compare and calculate, we're going to look at our change in miles here, so 76 minus 38, and put that over our change in gallons, 4 minus 2. 76 minus 38 is 38. 4 minus 2 is 2, and when you divide 38 by 2, you come up with 19, and this 19 is 19 miles per gallon. So now as we compare, the car is at 22 miles per gallon. The SUV, sport utility vehicle, is at 19 miles per gallon. So the car has a better miles per gallon by 3. So the gas mileage for the car is better. In real-world example 2, the function m equals 140h, where m is the miles traveled in h hours, represents the distance traveled of the first Japanese high-speed train. The distance traveled of a high-speed train operating today in China is shown in the table. Assume the relationship between the two quantities is linear. So, A, compare the functions y-intercepts and rates of change. First thing they do is to compare the y-intercepts. At 0 hours, no distance has been covered, so the y-intercepts are the same, 0. Then we go on to the rates of change. The speed of a Japanese train is 140 miles per hour, because that's what's in our function here. M equals 140h indicates that it's a 140 miles per hour. Like in example 1 where we had to calculate the slope or the rate of change from a graph, now we have to do the same thing but from a table. And you can see where they looked and said, okay, from 217 to 434, I'm going up by 217 per hour. Same thing from 434 to 651, I'm going up by 217 per hour. And so 217 miles per hour is the rate of change for the Chinese high-speed train. Now, if you ride on each train for 5 hours, how far will you travel on each? Well, the Japanese train were already given the function m equals 140h. And so we can put in 5 and go m equals 140 times 5 to get 700 miles in the 5 hours on the Japanese train. Now, find the distance by extending the table. That's one way of doing this for sure, where you can increase by 217 and 217 to get 1,085 miles in 5 hours. The other way that you could do this and say, okay, well, if my y-intercept was 0, I could say, well, my m equals that rate of change of 217 times h. So we can go, okay, m equals 217 times the 5 hours, and that's another way of getting to 1,085. So now we get to try this on our own. The number of new movies a store receives can be represented by the function m equals 7w plus 2, where m represents the number of movies and w represents the number of weeks. The number of games the same store receives is shown in the table, so we're comparing movies to games. Compare the functions y-intercepts and rates of change. So let's take this one step at a time. Let's start off with the y-intercepts. We're looking at our equation for movies. The y-intercept of the movies is 2. And we can pull that from the equation right here with the 2. Now, if we actually look at the rate of change here for the table, for the games, we're going up by 3 each week. Well, if we're looking at week 0, we can actually go, okay, we're actually going down 3. And so 3 minus 3 is going to be 0 new games at week 0. So for the y-intercept of games, we're simply looking at 0. Now what about the slope? For movies, we can pull that right here with the 7 next to the weeks. So this is going to be the slope of 7 per week for the movies. And with the games, we already did that with the table as we went up 3, so we can say 3 games per week. So the rate of change for games is greater. Now when we look at question C, how many new movies and games will the store have in week 6? Well, for movies, we can just use that equation. M equals 7w plus 2. And we can make a substitution in here. We're looking at the 6th week, so 7 times 6, then plus the 2. So movies will be 42 plus 2. So at week 6, we'll have 44 movies. Now there's 2 methods, at least, to get the number of games in 6 weeks. If we follow the book example, we extend our table 4, 5, 6, and then we just kind of simply add 3 for each line, which leaves us with 12, 15, and 18. So for games, it's simply going to be 18 games. The other way is to come up with an equation from the table where you can say, all right, games equals, our slope was 3, so 3 per week, and we had a y-intercept of 0. And so we can just make a substitution, and games equals 3 times the 6 weeks. So games can equal 18 that way as well. Now if we look at the example 3, financial literacy, Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y equals the 15 cents times x plus 49, where x represents the minutes and y represents the cost. Benjamin's monthly cost is shown in the graph. Again, compare the y-intercepts and the rates of change. Well, the function for Angela's bill has a y-intercept of 49. You can see from the graph that the function for Benjamin's bill has a y-intercept of 60. So Benjamin's y-intercept is higher, 60 compared to 49, which then means Benjamin has a greater initial cost. The rate of change for Angela's monthly bill is 15 cents per minute, and you can see that here. Find the rate of change for Benjamin's bill. Well, like example 1, we're going to take 2 points, and they decided to take the 060 and the 280. They looked for their change in cost, 80 minus 60. Their change in minutes, 200 minus 0. And you would get 20 over 200. And 20 divided by 200 is 10 cents. So the rate of change for Benjamin's bill is 10 cents per minute. And so Angela's was 15 cents per minute. Benjamin's was 10 cents per minute. So Angela pays more per minute than Benjamin. What will be the monthly cost for Angela and Benjamin for 200 minutes? Well, we have the nice pretty function here for Angela. So substitute in the 200 for the x, and you get $79 when it's all said and done. Now, it just so happens to be nice in the graph where we are given the point 200 minutes is $80 for Benjamin. So at 200 minutes, Benjamin will pay $80. I would like to real quick show you how to come up with an equation from that graph, because you're given the rate of change, or you figured out the rate of change, and you know the y-intercept. So if you simply use that idea of y equals mx plus b for slope-intercept form, and again, this is coming up with an equation for Benjamin, y is going to equal your rate of change for Benjamin was 10 cents, so 0.10 times x, and the initial value was 60. This will come in handy if you're asked anything else besides 0 minutes, 120 minutes, or 200 minutes to compare. And so now for our got it question, Mandy and Sarah each have a membership to the gym. Mandy's membership is represented by the function y equals 3x plus 29, where x represents the hours with the trainer and y represents the cost. The cost of Sarah's membership is shown in the graph. Compare the y-intercepts and rates of change. Let's start off with the y-intercepts. For Mandy, we can simply look at her function here. Look at this value here, and it's 29. So $29. As for Sarah, we can look at the graph at the point 0.39 and conclude that her y-intercept is $39. So we can conclude that Sarah has the higher initial cost. What about slope? Well, once again for Mandy, we can look at her function at this value of 3 and conclude that it's $3 per hour. So $3 per hour. As for Sarah, we're actually going to have to calculate. So what we're going to do here is take 2 points. Let's take the 451 and the 1275. And we will use our slope formula and compare their cost, $75 minus $51, to the hours, 12 minus 4. And this results in 75 minus 51 being 24 over 12 minus 4 is 8. And 24 divided by 8 is 3. So Sarah's is the same at $3 per hour. So we can safely conclude that Mandy and Sarah pay the same per hour. To finish now, what will be the total cost for Mandy and Sarah if they each have 4 hours with the trainer? Well, for Mandy, we can look at her function of y equals 3x plus 29. and substitute in the 4 hours. So this would be 3 times 4 plus 29, which is 12 plus 29, which is $41. And that's Mandy's cost. Now, it's not always going to be this easy to find the graph's cost, but you could look and say, all right, 4 hours for Sarah is $51. So on this particular question, we could say that Sarah was simply $51 by looking at the graph. Again, not always going to be that easy. So what I do want to show you is how to quickly come up with an equation here for Sarah. Again, if we just look at slope-intercept form of y equals mx plus b, we know the slope was $3 from what we calculated. We multiply that by x plus the y-intercept of 39. And so if we had to calculate 5 hours or 6 hours or 7 hours or 8 hours, it would be really helpful to have that equation. Having this equation just to show you how to work this through, you would substitute in the 4 hours, so 3 times 4 plus 39. That would be 12 plus 39, which is another way of getting to this $51 that's in your graph already. Now, if we look at our last example here, there's not an example that we have to go with this with our got it, so let's make sure we're paying attention as we go through this. Financial literacy. Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table and graph. Which company should she use to rent the truck for 40 miles? Now this question does not tell you, find the slope, find the y-intercept, now write an equation, now compare. But those are all the steps you need to successfully complete this question. Now, it says here, find the cost of renting a truck from Ron's Rental by extending the table. Again, that's one way of doing this. You extend the table by going, okay, we're going up by 10 each time. And so if we go up by 10 one more time, this will be 40 here. We're up by 10, up by 25 on this side, which is going to get us to 100. Again, one way of doing this. Another way, again, using our slope-intercept form here, we can find the y-intercept by going backwards. So if we go backwards another 10 miles, it should make logical sense that we're going to go backwards $25. So it leaves us with 0 miles, which is our y-intercept, and $0. So our y-intercept here is going to be 0. We can also then find the rate of change. We can find our change in cost, 50 minus 25, over the change in miles, 20 minus 10. And here I'm just using these 2 points to get us at 25 over 10. And when you divide that out, it's $2.50 per mile. So you can use that slope-intercept form here to say, okay, y equals mx plus b. Our slope-intercept is, or excuse me, our y-intercept is 0. Our slope is $2.50. So our equation is $2.50 per mile x. Why would we need to know this? Well, say you want to find 150 miles or 275 miles. It's not always going to be as easy as going into that next row. So if you have that equation, you can say, okay, y equals $2.50 times 40 in this question. And yeah, that's going to get you 100. And yeah, it seems like more work at first. But it's helpful to know in case it's not as simple as just looking at the next row. Now, what did they do for finding the cost of crosstown movers? They analyzed the graph. The y-intercept of the graph is 30, and you can see that right there. The slope, they took 45 minus 35 to get 10, 30 minus 10 to get 20. And so 10 over 20 is 1/2, or 5/10, 0.5. So they actually then did write an equation for this. They wrote y equals 0.5x, or 5/10 x, or 50 cents x, plus 30. So it's 50 cents per mile, but it has the initial cost of $30. So they actually then substituted in the 40, multiplied it by the 50 cents per mile, added the 30, and got $50. So cross-town movers would cost less for 40 miles. If you can work some of these things out by just extending a table, I suppose that's easier. It is. However, it's not always going to be as easy as the next row, so it's important to get these things into slope-intercept form. That's what they ended up doing with the graph anyways, and so that's what I would encourage you to do as well when possible, just to get that kind of practice. Now that is it for this lesson on comparing properties of functions. Good luck.